So the first equation, before I come to the Shah injection equation, I want to let you show why today suddenly I feel it is very important to know the deeper meaning of the fundamental physics that is involved to describe Shah injection equation and the material science for quantum nanomaterial type of object. So because in few cases we also have to make some non-linear non-homogeneous Hamiltonian system perturbed by external magnetic field or electric field or even heat energy. So today I like to show you what is actually going on here. Now let me give you another form of entire screen. Mm, just 1 minute. Mm. I hope now you can see entire screen over there. Now let's take a note from Shah that we often use to describe. So if you look carefully, the thermal de Broglie relation of Einstein equation is lambda equal to 2 pi of kBT. So I hope all know the basic deduction. If you me give you 1 second. So Ni plus Ne by Ni equal to 2 lambda q Gi plus 1 by Gi into the work epsilon by kT. This is actually epsilon of ion energy. This is the basic Saha injection equation you can see here. Now the question on who actually see the nuclear reaction formed a deuterium and a huge amount of energy to 231 mega electron volt or near about 200 mega electron volt for just nuclear fission of two hydrogen atoms happen in neutron star. So what Shah actually observed that if in lab nuclear fission reaction can give this amount of energy, it's fairly possible that in sun this atom present there. No one actually have seen said before Emin Shah. Actually, in Emin Shah in London astronomical physics lab, and he has worked with one professor. Mm, so in this research lab, they actually try to find out the spectrum of sunlight that is coming to Earth, and he analyzed this spectrum to find out what are the particles that can be. So he also have find out there sodium or potassium type of particle there might be in some because spectrum is actually showing that. But he also particularly also have also have few data in front of him that the hydrogen must be the main proponent of sun's energy, mm, sun's energy, and there will be a plasma environment. So the term look at the Ni is the number of density of the atom ionization state in K. Suppose if the hydrogen is come out of Ni number of the atom. Ni plus 1 number is the second ionization state. It means it actually ionized the second hydrogen as well. N is the electron density. Gi plus 1 the statistical weight, which is a degeneracy statistical weight. You know it is 2. Xi is the ionization energy, T is the temperature, Kv is the Boltzmann constant. So we all knows it. Now look at this at low temperature what happens. Exponential term small atoms remain the natural. Application used to determine localization hydrogen, helium, and stellar spectra. In plasma physics, degree of ionization is gas discharges. In semiconductor positive ion concentration N is the electron concentration by Ni will be 2 by lambda q h d Broglie wavelength, which is also defined by H cut square 2 pi m kb. Pi km is the phase shell. You know that in de Broglie 2 pi m is the full. So 2 pi lambda is the total circuit rate. T is a energy term. Now look at the ionization equation. Nin plus 2 into 2 pi kV 2 pi me kBt by hq. This is a 2 pi by 1 by lambda form. Then Gi, this to a degeneracy part, e to the power xi by kBt is the energy part of the system. This is actually should try it as a plasma system rather than individual small subsystem of a greater fusion reaction that is going on in sun. Actually, this is the plasma environment that creates the fundamental ionization environment. Then taking problem, what is the natural log problem then? Ln k equal to 3 by 2 ln t plus ln 2 into 2m pi by kbt 3 to the power 2 by h cube gi plus 1. So what actually we do in lab for calculation of the graphical term log k, this is our favorite term, this one. It is a log base 10, log 10 base k, this is ln, this is log 10, 3 by 2 log t log 2 pi into 2 pi kbt to इसका q g equal to 2.3 t kbt. This is a log term. So what we actually do is look closely. So the graph will be log k and log t. This is the graph that terms and well-known terms. So this term will get formed to determine the sun's temperature. This is why Jason Magnusha is so important, because he is the one who first tell us of mostly hydrogen. It is the hydrogen is full of in sun and the other particles are in a very lower number. That American, German, and the other scientists, Russian scientists, are do not actually convinced without showing the mathematical result. So it is someone Caroline Levitt from Harvard University who, after seeing this formula, wonderful, this is a wonderful formula. This is now proven to be true, that he actually said, let me use ionization equation. He used this equation and first time they see that they can tell the temperature of the sun from just following the spectrum of sunlight coming into the lab. So from lab data you can also tell the core temperature of the sun this way. So what I actually do, this is the C part. Sorry, this is actually C part. Mx plus C part. So look, what is actually do, the equation actually for log k it is proportional to 3 by 2 log t. So the exponential term becomes root over xi by t. Increasing temperature means the ionization will increases, which means more and more hydrogen will be ionized and the fusion reactor will have larger probability to occur. Same like higher ionization energy decreases ionization. Log Ni by N x 2 3 by 2 kBt plus constant. This is actually what happened. Yeah, there is nothing but by 2. So log t versus this 1 by t terms. This is the y, this is x, this is our c term, kind of c term, and this is also we take in consideration. Approximation log of Ni by Ni 3 by 2 log t x by 2 3 by f is equal to constant. This is actually our constant term. So let me show you. Let me show you the graph. Look, if you so in lab we also do the same work. Okay, in lab we got the data in master degree. So you get before it was actually done by PhD student, but nowadays MSc student also do. So log equal to chi up to 3y kb 1 by t y x c. This is a c part. This is a actually b part. I mean, so I, if you see the 1 by t versus this is actually the graph looks like. This is a 1 by t point log c. This is the c why it is arises. This is because of this constant term. The, this larger constant term. So this is actually arises. So look at how wonderful this data they generate. Sorry, there is actually little hindrance occur here. Just 1 minute, because so we see some hindrance. Just wait for a few minutes. How to look. Let me show you the hindrance. How actually ionization. Let me see if I can find any ionization equation possible. This is actually a simple, not so simple, but this is a characterization of my own research paper that I was actually done. Look, this is a simple experience. Experience intensity is nothing but the sign, kind of, I mean, the emission spectrum after exciting with the laser ultraviolet. So we find it how actually there is to peak actually happen in specific binding energy of this material, because if you working with some SN bus CE or Indian or gallium N type of semiconductor, which is nothing but in categories of quantum nanomaterial. High resolution of X-ray. This is the photoelectron spectrometer. So then this is actually the observation spectrum. Look how actually alpha h nu square through EV actually works for the two things. So my previous experiment was not only on this paper, but we have done it through two different temperatures to characterize this very properly, because you can increase a quantum computing system. This is very important, or radar system. Very defense equipment they use radar system. So what it will do is a PL spectroscopy from study. This is nothing but this is ignored. This is nothing important. How the wonderful graph. This is a log k versus 1 by t. This is a Megnath Shah Bose-Einstein equation. What actually the log k equal to x by t k equal to constant. What is the constant value? Value is 2 pi m kbt by hq. Yes, whole to the power 3 by 2 by hq. 2 pi m kbt. Now look how wonderfully the y equal to mx plus c. Is our m value is 2.34 kbt. The formula x equal to es is the constant part which we show right now. scrolling upside, and then the plot of the graph y-axis is equal to log k, y-axis is equal to 1 by t. X1 is as though short out very firmly, x equal to 1 by f. This is our final equation. Actually, if you see very carefully, in every book you will find this standard, uh, the standard value for x in the t is actually come, and t is actually come in the form of 10 to the power uh, 10 to the power 4 to 6, this range, not 3 but 4 to 6. This range is the observational value. I don't have core areas, but Megnadshaw is also important for quantum and nanomaterial researcher or material science researcher. Actually, astrophysicist students use this equation very much, but for the material science, it is also very analogous to use. So today actually I have seen one Megnadshaw is in Bosch and Sibira one. So I thought it would be very grateful to gather around the experiences the students should have. So let's um, let's go back. This is the research paper that I am talking about. But this is not actually a research paper. I also have our own research paper. Let me show you my own research paper. Why I think this is very analogous. Just a minute. Transcript. Just a minute. This is public. Look. This is the research paper that is bring the link we have. This research paper will show some variation instrument. Look, this is a TCS species. TCS species is nothing but a actually photon recoil emission spectrum from you can find the lifetime of alpha beta lifetime of alpha. The residual point is this one and this one tau. This is the value of the tau. The after how long seconds or picoseconds the actually emission happens, because from higher excited district to lower excited no, lower it might be excited, might not be excited. It's just in lower state the transition actually happens after the the radiation it occurs. This is the excited pattern that we find. uh, Pattern, just wait. I'll do my business paper file, full research paper, full, no, full file to open. The full research paper also actually this one, no, this one. Just a minute. I have actually full research paper which look at this. This is our research data. This one, this is the same intensity alpha h nu square. Look, this is nothing but h nu to the power n equal to h nu minus eg, and those are optical UV phase microscopy, and these characteristics, the absolute value them, and this one. Look here also. They have done almost same work. This is a work done by US university, a top level university and a university probably in Germany or Taiwan. They have collaboration. these two university actually published this research data. Just a minute, just a minute. Let me show you. Look. This is the absorption spectroscopy in 2D cadmium. So what do you find? 275 nano. Where it is fine? 305. So Ag value will be at 2.1 and ABS at 305 K temperature Kelvin at 2.21 electron volt, 2.31 electron volt when temperature is 340 K. In higher temperature, you will find the energy will be higher. I mean, the in absorption spectral energy will be higher. And this is the absorption coefficient as well. This is the nature of absorption coefficient. Look, 1.52 gap, 1000, 1.5. Absorption coefficient is looks almost same. Okay, so this is all for now, and then this is another emission spectroscopy that we actually have worked on this area, and this is very important TCS species. So people who want to do serious research, they should focus on these areas. Now, why? Yes, I can do much more complex theoretical research paper as well, which I also have one. I have shown you few days ago as well. Entropy actually works. Okay, so in those cases, what we have to do, you have to normalize matrix, you have to form density matrix differently. This is actually theoretical work, plus mostly astrophysics people do this kind of work, and this is a very good research paper, honestly. Very fearful and good research paper. It is actually published by a university. Okay, now question is, but they are not actually into more productive work, because quantum computing and the quantum microprocessor will be next areas where the job will be created and the work will be done most. But my personal experience in my university is not doing actually on these areas of physics. Thank you. So let's close the stream and